So number 4 reads, a uniform electric field of magnitude 413 Newton per Coulomb pointing in the positive x direction acts on an electron, which is initially at rest. The electron has moved 2.80 centimeters. What is the velocity of the electron at the end of this range? So in order to solve this problem, you can't just simply go into and solve for the velocity right away. You actually have to use the electric field information that we're given to solve for the force. And then once we have the force, we're going to use Newton's second law to solve for acceleration. And then lastly, once we have the acceleration tied together with all this information, we can use a kinematic equation to solve for the final velocity. So like I said, first we're going to use the electric field equation, which is E is equal to F over Q, which is force over charge. And then so we're given the electric field, so that is 413 Newton per Coulomb is equal to force. And we're not directly given the charge, but since it's an electron, we know that an electron has the elementary charge of 1.6 times 10 to the negative 19 coulombs. So our force, put that in a calculator, our force is equal to 6.61 roughly times 10 to the negative 17 newtons. And so we can use this force here by plugging it in to Newton's second law. So force is equal to mass times acceleration. The mass that we're going to use is the mass of an electron. So this is 6.61 times 10 to the negative 17 newtons is equal to the mass of an electron, that is 9.11 times 10 to the negative 31 kilograms. And then just solve for our acceleration. So I'm going to divide the force by the mass of an electron. So that's going to give me an acceleration equal to 7.25 times 10 to the 13th power. And that's meters per second squared. And so the kinematic equation that I want to use is the one that has the distance, final and initial velocity, and acceleration. So that is v final squared minus v initial squared is equal to 2 times acceleration times delta x. And so it says that the electron was initially at rest, so I can put a 0 in for the initial velocity. And then that will be 2 times, I can plug in my acceleration is 7.25 times 10 to the 13th. And then my delta x, it says the electron has moved 2.8 centimeters. So 2.8 centimeters is, we're going to want to convert that to meters just for consistency of units. And then so that will be 0.028 meters. So I can quickly use my calculator and solve for that. Multiply the acceleration by 2 and then multiply that by 0.028. And then so I'm left with v final squared is equal to 4.06 times 10 to the 12th power meters per second. And then so since this value is squared, I'm going to take the square root. And that's going to leave me with an answer of 2.02 times 10 to the 6th meters per second. And then so if I see that answer is A, so the answer for number 4 is A.